Okay, today I will discuss with another principle of plant disease management or plant disease control, that is host resistance. So, you know, when the plant is exposed to the natural environment, the plant might suffer from a number of diseases, you know. If we cannot avoid the pathogen, if we cannot exclude or protect, or we can eradicate the pathogen, then still we see that the plant is not suffering from disease. Then we called it the plant is resistant plant. Another term we call susceptible plant. If there is disease in the plant, although we could not eradicate the pathogen or protect the plant or avoid the pathogen, but still the plant is suffered by the diseases. We call the plant is susceptible. So what is resistance and what is susceptible of plant? Resistance, this is the ability of the plant to resist the growth of the pathogen, development of the pathogen, and reproduction of the pathogen, and consequently the disease of the caused by the pathogen. So this is the ability of the host plant to resist or to hinder the growth, development, and reproduction of the pathogen, and thereby to resist the disease caused by the pathogen. So this is the ability of the plant. This is a relative term, and this resistance of the plant can be expressed at any stage of the development of disease. Maybe the resistance of the plant initiates at the early stage of the disease development, maybe at the later stage of the disease development. And the resistance is expressed as morphological and biochemical. So when the plant is exposed to a number of biotic and abiotic threats, then the plants change themselves. You see, the cuticle of the plant will be thick. There will be deposition of waxy layer on the plant surface. So these are all morphological resistance. As a result, the pathogen cannot invade the plant easily, cannot enter the plant easily because of hard and thick cuticle, because of waxy layer on the plant surface. And on the other hand, when the plant is attacked by a number of pathogens or exposed to a number of biotic and abiotic threats, then there will be some changes in the metabolic process of the plant. And because of the changes of metabolism, the plant will produce some chemical inside the plant. Those chemicals are toxic for the pathogen invading the plant. Those chemicals can kill the pathogen. You understand? So these are biochemical resistance. For example, I told you that the production of phytoalexin inside the plant. So this phytoalexin can resist the growth of the pathogen, the development of the pathogen, and reproduction of the pathogen inside the plant. Even this chemical can kill the pathogen to some extent. So these are known as biochemical resistance. Then we can classify the host resistance based on a number of criteria. For example, based on the genetic, we can classify host resistant as monogenic resistant. The resistance which is controlled by one gene, single gene, we call it monogenic resistance. And on the other hand, the resistance which is controlled by two genes, we call this oligogenic resistance. And polygenic resistance is this resistance controlled by several genes, multiple genes, many genes. And another resistance, those are not controlled by the nuclear gene or the DNA, but by the other part of the cell, extra chromosomal resistance. That is the cytoplasmic resistance. For example, the Texas male sterile lines in maize, it's in the USA available in the USA. This line is resistant to southern corn leaf blight disease caused by the fungus Bipolaris medis. So these are the resistance or host resistance we know. Then you see the horizontal resistance and vertical resistance. The resistance is classified again. Vertical resistance is one which is controlled by one or two genes. And this resistance is effective against one or some races, not all races of the pathogen. And this actually decreases the initial inoculum of the pathogen. It does not decrease the rate of the virulence races, and thereby it controls the epidemic, or it checks the epidemic. On the other hand, horizontal resistance is controlled by many genes, and this resistance is effective against all races of the pathogen. The same species of the pathogen have several races. For example, Bipolaris oryzae, this is a species of the pathogen. This pathogen might have several races in the environment, in the natural environment. So in this case, if the plant is resistant horizontally, then this plant should be resistant to all the available races of Bipolaris oryzae, for example. And this resistance reduces the rate of spread of disease. It does not decrease the initial inoculum, but it reduces the rate of the epidemic, and consequently it slows down the epidemic. You know what is epidemic? That is the sudden outbreak of the disease. We call it epidemic. Let's say one plant is infected with the pathogen today, and if you see there are thousands of plants become infected tomorrow, then this condition we call epidemic. That is the sudden development and spread of the disease within a very short period of time. We call it epidemic. Then let's see the differences between vertical resistance and horizontal resistance. Sometimes we ask you in the Viva Voce or in the exam, then what are the differences between vertical resistance and horizontal resistance? By this time, you already know some differences. That is, one is monogenic or oligogenic. Another one is polygenic or controlled by many genes, horizontal resistance. The several names of horizontal resistance, there are some alternate names, for example, race non-specific resistance, minor gene resistance, quantitative resistance, general resistance, durable resistance, or partial resistance. The same thing. Horizontal resistance is known as with this term. On the other hand, vertical resistance is also known as field immunity, hypersensitive resistance, major gene resistance, qualitative resistance, gene resistance, race specific resistance, and specific resistance. So these are the same thing. Vertical resistance is temporary resistance, but provide a complete control of disease against specific race. Because this resistance is controlled by one gene or two genes. If the pathogen can modify this one or two genes, then the resistance breaks down. So that is why we call vertical resistance is a temporary resistance. But although this resistance is controlled by one gene or two genes, but this resistant plant take the pathogen completely, not partially. Okay. On the other hand, the horizontal resistance is permanent resistance. It is durable resistance. We also called it, because this resistance does not break down because this is controlled by many genes. Maybe the pathogen can modify or can disrupt one gene, conferring resistance to the plant. But there are available genes, other available genes conferring resistance. As a result, horizontal resistance does not break down, or it is not, or this resistance is permanent, we call it. And this horizontal resistance slows down the epidemic. It does not control the epidemic, but it slows down the epidemic. On the other hand, this vertical resistance completely check the epidemic. So if there is one plant infected today, at the very beginning of the establishment, this vertical resistant plant will control this inoculum, or will kill this inoculum, or will make the inoculum ineffective. As a result, this vertical resistant plant check the epidemic. There is another term we call apparent resistance. You see, this is a term, although the plant is not resistant itself, but it seems to us that the plant is resistant. It happens when the susceptible stage of the plant does not coincide with the pathogen. And you see here, it might happen because of non-coincidence of susceptible stage with the favorable condition of the pathogen, or it may be because of fast growth rate of the host compared to the pathogen, and maybe because of mixed cropping or age of the host plant. And another term we called disease tolerance. This is the ability of the host plant to tolerate the presence of pathogen, or to produce a healthy crop, although there is pathogen in the plant. We call this disease tolerant or tolerant plant. Let's have a look. The resistance and tolerant of the plant. Sometimes we ask you, what are the differences between resistance and tolerance of the plant? So when we think about resistance, we consider the number of pathogen, or we consider the amount of pathogen. Listen carefully. When we think about the resistance, we talk about the number of pathogen, or we talk about the amount of inoculum present in the plant. Let's say this is a chili plant. Both are chili plants of same age. Let's say we inoculated 100 root knot nematode to this plant a month ago. And similarly, we also inoculated 100 second stage juvenile of root knot nematode in the right-hand side plant 1 month ago, for example. So both plants were infected by 100 second stage juvenile of Melodogyne species 1 month ago. And let's say today we check this plant, the both plants, and we got 200 second nematode, for example, total number of nematode in this plant, and 1,000 nematode from this plant. Today, for example, 1 month ago, we inoculated only 100 nematode in both plants, and after 1 month, we get 200 nematode from this plant and 1,000 nematode from this plant. Then which one is resistant and which one is susceptible? You can see here, this one is resistant. The left-hand side we call resistant, and the right-hand side we call susceptible. You see it? So when we talk about the resistance, we think about the number of pathogen or the amount of inoculum. Let's say instead of nematode, we infected the both plants with fungus, for example, with bacteria. In that case, we cannot count the number of conidium and spore of fungus and bacteria. Rather, what we could do, we could actually quantify their amount. There are a number of methods of quantifying the amount of pathogen by molecular techniques, qPCR. This is such a technique by which we can actually quantify the amount of pathogen inside the plant. qPCR, we can identify the pathogen and we can quantify the pathogen with the help of a molecular technique. We call it qPCR, quantitative polymerase chain reaction, that is known as qPCR. Okay, so if we get, for example, 200 nematode after 1 month, and if we get 1000 nematode after 1 month from this plant, then this plant is known as susceptible and this plant is known as resistant, because this plant resists the growth, development, and reproduction. That is why their number is only 200. And this plant cannot resist their growth, development, and reproduction. That is why their number increased exponentially. You can see here from 100 to 1000. So this is known as susceptible plant. Then when we talk about the tolerance of the plant, we don't think about the number of pathogens. Rather, we think about the plant size, shape, and structure. We think about the plant canopy. You can see here, both are chili plants of same age, both are healthy plant. For example, we inoculated 100 second stage juvenile of melodogain. In this plant left-hand side, we also inoculated the same number of nematode, that is 100 second stage juvenile of melodogain species in the right-hand side plant. And let's say, today we got this, this plant looks like this one, and today this plant looks like this one. You can see here, the growth, development, and reproduction of the plant is not affected in this case. You can see here, but in the right-hand side, the growth of the chili plant, the development of the chili plant, and reproduction of the chili plant is affected by the presence of the nematode. You can see here, there is no growth of the plant. Before 1 month, the plant looked like this one, and after 1 month, this plant looked like the same, for example. That is, the growth, development, and reproduction of the plant is affected in this case. On the other hand, in the left-hand side, the growth, development, and reproduction of chili plant is not affected. That is why we can see that the plant increase in size, shape, and structure, and they develop. They also go for reproduction. You can see there here the chili fruit. Okay, so this is known as the tolerant plant, the left-hand side, and this is known as intolerant plant, because this plant cannot tolerate the presence of the nematode. On the other hand, the left-hand side, this plant tolerate the presence of nematode. You see here, both plants were infected with the same number of nematode. But after 1 month, this plant transformed to this plant, and after 1 month, this plant remained the same. So this is known as intolerant. So listen carefully. When we talk about resistance, we consider the number of pathogen or amount of pathogen. But when we talk about the tolerance of the plant, we consider the plant size, shape, and structure, plant canopy, plant biomass. You can see here. We think about the plant biomass when we think about the tolerance. So the tolerant plant might be resistant or might be susceptible. You see here. On the other hand, intolerant plant might be resistant or might be susceptible. On the other hand, the resistant plant can be tolerant and intolerant, and susceptible plant can also be tolerant and intolerant. So there are 4 combinations. You can see here: resistant tolerant, resistant susceptible intolerant, and tolerant resistant tolerant susceptible. Or actually there are 8 combinations: susceptible, resistant, tolerant, susceptible, intolerant, and intolerant, resistance, intolerant, susceptible. So what kind of plant we actually need to boost up the production? We need resistant tolerant plant to boost up the production. Okay. Then how can we actually develop the resistant variety? Resistant variety to a specific pathogen, for example. There are a number of ways, traditional methods, advanced method, molecular methods, you can see here. So we have to select a variety that is resistant. And you know that the resistance of the plant is compromised with the yield. You know, the wild variety is resistant to almost all disease, but the yield of the wild variety is not high, very minimum yield. But the plant is resistant, you know, the wild variety. On the other hand, the popular variety gives us maximum yield. But this popular variety is susceptible to a number of diseases. That's the problem. So we need both resistant variety that is high yielding also, but this is not coincide in the normal conditions. So what we have to do, we have to make the high yielding variety resistant. So how can we do this? We have to select the wild variety that is resistant, and we have to look for a high yielding variety. Normally those are susceptible. Then we have to cross these resistant and susceptible parents. This is a hybridization process. It normally takes 7 to 10 years to make a high yielding variety resistant to a particular disease. So this is known as conventional breeding method. So by breeding, we can transform a high yielding susceptible variety into a resistant high yielding resistant variety. So there are another methods you see here, we call it mutation. Mutation means sudden, abrupt, we call sudden or abrupt changes in the genetic material of the plant. By a number of ways, we can mutate the plant. For example, by using different rays, X-ray, beta ray, gamma ray, UV rays. You know, Bangladesh Institute of Nuclear Agriculture, this institute, the scientists of this institute use a number of rays to cause mutation in the susceptible variety. And after mutation, they check whether they remain susceptible or not, whether they become resistant or not. So by several trials, they might be able to produce a resistant variety by using different physical mutagen, X-ray, alpha ray, beta ray, gamma ray, and UV rays. Sometimes they also use some chemical that induce mutation to the plant. You know, ethyl methane sulfate. This is one example of chemical. There are some chemicals which induce mutation in the DNA structure of the plant, even in the DNA structure of human being, of other being. There are some chemical, mutagenic chemical, we called it. So they expose the plant to the chemical, and after that they check whether there is mutation or not, or after mutation whether the plant transformed to resistant or not. Then there are some other techniques by which we can make the host plant resistant. You know, host nutrition. That is, we have to provide balanced nutrition to the plant. Okay? So by providing balanced nutrition, we can make the plant resistant to biotic and abiotic threats. How does it actually occur? What happens if we don't provide balanced nutrition in the plant? Let's say, if we apply excess nitrogen fertilizer, nutrition means, you know, there are essential nutrient elements, carbon, hydrogen, oxygen, nitrogen, phosphorus, potassium, calcium, boron, zinc. So these are the nutrient element, essential nutrient element for the plant. So if we apply high dose of nitrogen, for example, then what happens? The vegetative growth of the plant is promoted. As a result, the plant becomes soft and succulent. So when the plant becomes soft and succulent, then the pathogen can enter the plant easily and can cause infection. So when the vegetative growth is promoted, then because of wind, that plant breaks down. And when the plant breaks down, then bacteria enter the plant through the injury, As a result, the plant becomes susceptible. On the other hand, when we apply, for example, less amount of potash fertilizer, MOP, because the price is high, the price of MOP fertilizer is high compared to the urea fertilizer. As a result, the farmers apply urea fertilizer frequently. On the other hand, they don't apply sufficient potash fertilizer, MOP, in the field. And the function of potash in the plant. Potassium makes the plant hard, strong, and stiff. As a result, this plant will not break down because of wind. And this makes the plant strong, stiff. As a result, the plant itself becomes very strong, and pathogen prevailing in the environment will not be able to cause infection to the plant. So this is the way we have to provide all the essential nutrient element to that particular plant. And we also have to maintain the balance or ratio among the nutrient. Okay? So if we don't provide all the essential nutrient element, what happens? The plant cannot complete the life cycle. That is, seed to seed. We may sow the seed in the field. That seed may be germinated. Seedling might be produced, or that seedling might be transferred to the old plant or matured plant, but that plant will not produce flower. The plant might produce flower, but that flower will not be transformed to fruit. Maybe the plant might produce fruit, but there will not be any seed formation. That is, the plant cannot complete the life cycle in absence of only one essential nutrient element out of 17. So these are the significance of essential nutrient element or host nutrition. So we have to provide all the essential nutrient element. In addition, we have to maintain the balance, or we have to maintain the ratio among the nutrient. So if we do this, we call it balanced nutrition, and this balanced nutrition makes the plant resistant. Okay? So there are another techniques we see here, cross protection. This is the principle by which the scientists prepare the vaccine. There are other principles of vaccine preparation, but this is one of the principles of vaccine preparation. You understand? So what is it? Let's say the plant is there is very notorious races of bipolar rhizosphy that causes brown spot disease to rise. So what we have to do? We have to look for the virulent races of bipolar rhizosphy. Okay, so there are virulent races of bipolar rhizosphy. There are avirulent races also available in the environment. So we have to look out for the avirulent races of the pathogen, and the plant should be exposed to the avirulent races of the bipolar rhizosphy. As a result, this plant becomes resistant to the virulent races of bipolar rhizosphy. So this principle is known as cross protection. Okay, so we have to use the avirulent races of the pathogen of the same race species, and we have to use these avirulent races to make the host resistant to the virulent races. So the use of avirulent races is known as cross protection. Then other mechanism of resistance, that is we call induced resistance. That is, we have to induce the plant by applying some hormone. For example, we can apply jasminic acid. This is the hormone. Salicylic acid, gibberellic acid, auxin, cytokinin. If we apply this hormone to the plant, then this hormone induce the resistance inside the plant by activating the different metabolic reaction inside the plant. As a result, the plant become resistant. And sometimes we can use coat protein, CP. Or we can use coat protein to induce resistance inside the plant. And sometimes we can transfer the resistant genes from the alien species. For example, BT gene is transferred from the bacteria Bacillus thuringiensis to cotton, for example, or to brinjal. As a result, that brinjal or cotton become resistant to the shoot and fruit borer. So this gene is actually present in the bacterium, but we can identify the gene and we can transfer the gene from bacteria to the plant. As a result, that plant produce toxic substance. The substance is toxic to the shoot and fruit borer. That is the genetic engineering approach. More advanced method nowadays are being used. For example, CRISPR-Cas technology. You learn it in level 4 or in master's level. CRISPR-Cas technology, genome editing technology. We can identify the gene, then we can cut the gene, and we can transfer the gene to the host. So this is known as CRISPR-Cas technology. Yes, by this way, we develop the resistant variety. But development of resistant variety is a continuous process. That is, the variety that we develop this year may be resistant this year only, may not be resistant in the coming years. Okay? So what we have to do? We have to manage the resistance. And these are the methods by which we can manage the resistance of the host plant. That is the pyramiding of vertical genes. That is, we have to identify several genes in the natural environment, and we have to accommodate those several genes in the same host plant. We call it pyramiding. Okay? Then you know that the plant which is resistant in Mymensingh may not be resistant to Pabna or may not be resistant to Chittagong. So that is, we have to identify the gene and we have to give it trial to the different region. And we have to look which gene is resistant for which region. Okay? And by this way, we can actually maintain the resistance over the years. We can rotate vertical genes, or this is known as gene cycling. That is, so we have to actually take several line or cultivar or varieties having several genes. So the same gene should not be cultivated in the same land years after years. Okay. For example, we got 5 gene. Number 1 gene can be cultivated this year. Then the number 2 gene can be cultivated in 2022, or 3rd gene can be cultivated in 2023. So in this way, we can rotate the gene. We call it gene cycling or rotation of vertical gene. So we have to maintain a number of resistant variety, cultivar and line. We have to mix it up, and by mixing this one, we can actually maintain the resistance. Otherwise, if you use the variety having only 1 gene, that gene might be disrupted by the pathogen. And if this single gene is disrupted, this plant will be susceptible completely in the next year. And that is why, to prevent this one, we have to mixture several genes, and we have to cultivate this host plant in the coming years. So that is another principle we call therapy. You know, this actually refers to the treatment when the patient is suffering from cancer disease. We call it chemotherapy, for example. But in case of plant, we also call therapy, and we use these 3 terms: chemotherapy, thermotherapy, and tree surgery. That is, chemotherapy means use of chemical. Thermotherapy means we can use heat to control the pathogen. Maybe high temperature, maybe very low temperature. And tree surgery means we have to dissect the infected plant part. We have to remove the infected plant. After removal of infected plant part, we have to use some chemicals to the region of dissection. We call it tree surgery. So these are the principles of plant disease management. I have discussed principles: avoidance of the pathogen, exclusion of the pathogen, eradication of the pathogen, protection of the plant, then host resistance and therapy. So these are the 6 principles of plant disease management. Okay. So this is all about the principle. Then I have to talk about another slide, that is the quarantine. Very simple one. You already know what is quarantine or what is quarantine, plant quarantine. That is the legal restriction of the movement of plant or plant product from country to country during export and during import. So the legal restrictions that are used to control the movement of the plant and plant product during import and export, we called it plant quarantine. So we import a number of plant and plant product from the foreign country. For example, we import rice. Nowadays, we are self-sufficient in rice production, but in the recent past, we had to import rice. We also import wheat, maize, raw cotton, fresh fruits, for example, pulse, oilseed, spice, timbers, vegetable, and a number of other products. For example, jute, tea, tobacco, vegetable foods, frozen vegetable foods, then foodstuffs, handicraft, aromatic rice, and spices. So these are the plant and plant product we import from the foreign country. Okay. We not only import, but also export to the foreign country, mainly vegetables and fruits. And you see here the role of import and export and the role of agriculture in the economy of Bangladesh. You can see here the 22% of GDP comes from agriculture, and 8% of the total export is from plant and plant product. We export a number of product to foreign country. So among the export, only 8%, about 8% of export comes from agriculture source. And nowadays we are exporting fruits and vegetables to a number of countries, mainly in the Middle East and in the European countries where Bangladeshi peoples are residing. Bangladeshi students, immigrants, workers are residing, mainly to those countries. So our exported foods are mainly consumed by the immigrant minded in the country where our people residing. And you can see here 6.2% of total arable land is under horticultural crop. Among about 3.2% are potato and spice. So we export our product, vegetable and fruits, to a number of countries. You can see here, this is the lion's share UK. We export mainly in the UK because there are lots of Bangladeshi people residing in the UK. You can see here, we also export in this, to the South Africa because there are lots of immigrants. We also export to Kuwait, Qatar, United Arab Emirates, Bahrain, Italy, and to other countries. So you can see here the proportion of export to this country because in the UK, many Bangladeshi people are residing. You can see here, we export to mainly in the European Union and in the Middle East. You can see here, the marketing channel are largely controlled by the middlemen. And direct linkage between producer and exports are very weak because of the presence of middlemen. And the retailers and importers operating in these markets are looking for better quality product and packaging. So they look for better quality product and they look for good packaging. So these requirements are very difficult to meet for the developing countries like Bangladesh. Okay, so the exporters have different standard. That standard is really difficult to meet up. So to survive in this competitive international market, standards given by the developed countries have to be complied with. Otherwise, they will not import fruits and vegetables from Bangladesh. But mostly we failed. You can see here, more than 20% of the horticultural exports are made in the Middle East. And this is relatively easy than the European countries. They only need plant health certificate, mentioning that the exports are free from pest, insect, and disease. And this is easier than European Union. And recently, citrus export from Bangladesh has been restricted because of the presence of Xanthomonas axinopodes, because of the presence of Sarcospora angolensis and Guignardia cyticarpa. Because of presence of these pathogens, these are the quarantine pathogen for the European country and for the Middle East countries. So as a result, the citrus having this pathogen in Bangladesh are not allowed to be imported in the Middle East or in the So they declared that the food shall be free from this pathogen, and this food shall be free from peduncle and leaves, and packaging shall be an origin mark that is made in Bangladesh. And the food should be treated with substance like sodium orthophenylphenate before export. And you can see here, this is the Plant Protection Service system, that is we call National Plant Protection Service system. There is officer we call National Plant Protection Officer. He is the responsible person during import and export. He is the responsible person to deploy the legal restriction during import and export. You can see the organogram here, Director of NPP, and there are additional director you can see here, and there are deputy director for plant quarantine, deputy director for pesticide administration and quality control, deputy director for surveillance and forecasting, deputy director operation, especially in aerial and ground. So BCS agriculture officers are recruited in the Department of Agriculture Extension under the Ministry of Agriculture, and there is an organogram like this, for example. And we have plant quarantine center all over the country. You can see headquarters, 3 international airport, 2 seaport, 1 river port, and there are 20 land port where plant quarantine officers are employed to check the presence of pathogen during import and export. How this system introduced in Bangladesh? Actually, British government declared the Destructive Insect and Pest Act in the year 1914. Later on, in 1966, the Pakistan government endorsed the act of British government. And after liberation, the Bangladesh government in 1974 became the member of International Plant Protection countries. You can see here, later on in 1989, Bangladesh amended the Destructive Insect and Pest rules. So that was formulated in 1966. And Plant Quarantine Act 2011 has been passed recently. Now, new rules yet to be formulated. These are the existing plant quarantine center after liberation. You can see here Seaport Chittagong, Seaport Mongla Khulna, Darshana Landport, Chuadanga Benapur Landport, Hazrat Shahjalal International Airport, Dhaka, Shah Amanat International Airport. So these are the quarantine stations. In this quarantine station, there are 6 mainly. Quarantine officers are employed to detect, to identify, and to issue the phytosanitary certificate. There are other quarantine stations you can see here established after 1988. You can see here Shona Masjid Landport in Chapainawabganj, Hili Landport, Dinaspur, Burimari Landport, Lal Monirhat, Teknaf Landport, Cox's Bazar, Akhaura Landport, Bamonbaria, Tamabil Landport, Silet. So these are the other 14 stall port across the country, also one in Moiminsing, Halwaghat Landport. So the plant quarantine officer need the list of the pathogen. Which one is quarantine pathogen or which one is quarantine pest? And listing of pest, quarantine pathogen actually have started with citrus crop since 2010. And after all, this process is being continued. We are preparing the quarantine pathogen. The pathogen which is quarantined for Bangladesh may not be quarantined for India, for example. And the pathogen which is quarantined in India may not be quarantined in Bangladesh. Okay, so we have to prepare a list for Bangladesh. Okay. So that is another term. We have to analyze the pest. So we will not consider all the pathogens as quarantine. We only consider the important one. So we have to survey to know about the importance of the pathogen, to know about the incidence and severity and the destruction caused by the pathogen, and only those pathogens will be enlisted as the quarantine one. You can see here, we didn't prepare any pest until 2010, but after that we prepared test. And nowadays, a project has been taken to develop or to strengthen phytosanitary capacity in Bangladesh. And this project include, we have to upgrade quarantine laboratory in the country. We have to develop the capacity for the quarantine officer by providing training. We have to conduct pest risk analysis. We have to list this year. We have to establish, you can see here, a pest-free areas, and we have to improve the packaging facilities. So these are the tasks to be done under this project. As a result, we can develop the phytosanitary capacity in Bangladesh after implementation of all these methods. So, you know, the plant quarantine service is very important, and this service is regulated by Plant Protection Service, the Department of Agriculture Extension under the Ministry of Agriculture. These actually responsible to combat the insect and disease of different crops. So nowadays, safe food production through IPM process created a great enthusiasm among the producer and consumer under the direct and positive guidance of different government agencies. For example, DAE, then Hortex, another foundation we call responsible for the export of the horticultural crops. And the government is also considering good agricultural practice. Good agricultural practice to facilitate the export of different products. So this is all about the plant quarantine. Now I will give you the time to ask question. Any question?
Sir. Sir.
Yes, tell me, please.
Sir, cross protection e bolছিলেন যে মানে exposed to virulent মানে virulent race গুলাকে against virulent race এর against use করব স্যার এটা কিভাবে করব?
Okay, for example, we have to identify the virulent races of the same pathogen, then we can apply these virulent species to the environment. As a result, these virulent species will already occupy the plant. As a result, the virulent species will not get any space in the host plant, or there will be competition between virulent species and avirulent species, and in this competition, avirulent races win. As a result, virulent species cannot cause infection.
Sir,
yes.
Sir, the coat protein একটা example দিবেন?
I cannot give you the example at the moment, but we can use coat protein. Mainly genetic engineering. Coat protein is synthesized from the gene, and that mainly from the resistant gene. And this protein we have to apply to the plant to induce resistance.
Yes, sir. And sir, TMS full meaning কি?
The Texas male sterile.
Yes, sir. ঠিক আছে। ধন্যবাদ স্যার।
স্যার একটা কোশ্চেন ছিল।
Yes, tell me.
স্যার 8টা কম্বিনেশন যে বলেছিলেন সেটার মাঝখানে রেসিস্ট্যান্স এর সাথে কম্বিনেশন হচ্ছে ইনটলারেন্ট হতে পারে স্যার এটা কখন আর হচ্ছে কিভাবে হবে এটা কিভাবে বুঝবো
Okay, the resistant plant, when you talk about the resistance, you count the number of pathogen after inoculation. And when you see that this resistant plant is not affected by the presence of pathogen, and you have to check the growth of the plant. You have to check the size of the plant. If you see this resistant plant, for example, there is no multiplication of pathogen, but this plant is still dwarfed. For example, the size is not changed, is not increased, then this plant is intolerant. But if you see the plant is resistant, that is the multiplication of pathogen is retarded, but still the plant increase in size and shape. And that resistant plant is tolerant.
স্যার যদি রেসিস্ট্যান্স হয়ে যায় তাহলে স্যার ইনটলারেন্ট হবে কেন
Okay, that's the question. The resistant plant. Here, the growth of the plant will be compromised with the presence of pathogen because of competition of nutrient. The pathogen also need nutrient. So while the plant, let's say the plant is infected by thousands of pathogens, let's say, then those 1,000 pathogen will take nutrition from the plant. As a result, the plant does not get enough nutrition for growth and development. As a result, their growth is compromised and that plant become intolerant.
জি ওকে স্যার থ্যাংক ইউ
Any question?
pyramidingটা কি বলেছিলেন
Gene pyramiding, that is, we have to identify several resistant gene and we have to accommodate all those resistant genes in the same host plant. We call it gene pyramiding.
স্যার একটু আরেকবার বলবেন জিন পিরামিডিংটা
That is, there are several resistant genes might be available in the environment. We have to identify those several Earth gene and we have to transfer those several Earth gene in the same plant. In the same host plant, we call it gene pyramiding. Got it?
yes sir thank you
Okay, time is up. So this is all about my part. Professor Dr. Ali Hussain will start on next Monday.
Attendance sheet.
I have given the attendance sheet in the chat box. Please fill it up and send it to me.
স্যার আমাদের একটু শীটগুলো দিয়ে দিবেন
Okay, I will give you the sheet next week. Okay. Okay, see you in the practical class.
Okay, sir. Thank you, sir.